Cybercriminals are working overtime. Last year in the fourth quarter alone, phishing attacks disguised as COVID testing information increased by 521%. Barracuda has identified 13 types of email threats and how cybercriminals use them to steal money from your company or personal information from your employees and customers. Find out about the 13 email threat types and how Barracuda can provide complete email protection for your teams, your customers, and your reputation. Get your free ebook at securityweekly.com/Barracuda. That's securityweekly.com/Barracuda. Welcome back, everyone, to Paul's Security Weekly. I believe I have an announcement for this segment. Security Weekly listeners save up to $100 on your RSA Conference 2022 full conference pass. The RSA Conference will be held in San Francisco June 6th through the 9th, 2022. Security Weekly will be there in full force. Not me, because it's my son's birthday, but we'll be delivering real-time live coverage and interviewing some of the event's top speakers and sponsors. To register using our discount code, please visit securityweekly.com/RSAC2022 and use the code 52UCyber. We hope to see you there. Except I won't see you there. Well, I might see you there, but maybe virtually. In any case, joining us for this interview is none other than Jay Beale. Jay works on Kubernetes and cloud native security as both a professional threat actor and in his open source work. He's the architect of the Peirates. Is that like Pilates, but Peirates attack tool for Kubernetes, and the Bastille CTF cluster. We definitely did not rehearse the pronunciation of those things, because you said it on the call earlier.
Peirates.
Jay, welcome to the show.
That was awesome. I thought you were. I literally thought you were just having fun when you got to Bastille. I'm like, whoa, what are you doing?
It was kind of like Bust a Move, because you're like a dancing maniac. I can never get that out of my head when there's a video of you dancing in a conference, and then you were Jay Beale, the Dancing Maniac was your nickname in the show. When we refer to you, that's how we refer to you on the show. I don't know if the nickname stuck outside of the way we referenced you on the show, but that's how we did for a long time, and it won't leave my head.
It's stuck around a little bit.
Still
stuck around. I'm a little older. I'm a little less hyperactive now than before. Not
less nimble. You're still nimble. You stretch every day.
No, I just move. You just got to keep moving, duck and dodge.
So Jay, you've been in security for a really long time. Us old folks.
Thanks for calling him old.
Right? Us old folks remember Bastille Linux, right? You still do anything with that project? What's the conclusion or continuation?
I mean, I so wish it's been forever. Bastille was awesome. It was like a hardening program to kind of get people to lock down Linux systems, and back when they weren't very locked down, and they've become much tighter nowadays, and very much because we've had so many worms, so many automated threats. There's just no room for the kind of like super unhardened Linux machines we used to see. But yeah, it was a fun project I worked on with a bunch of other people for a while, and it was like the big thing that we liked in Bastille was like, we're like, hi, we'd like you to turn off Telnet, replace it with SSH or whatever. And we realized like no one's going to know why we're asking them to do these things. And so we built in this kind of educational component to like say, hey, it turns out, unencrypted protocols, they could be eavesdropped on. And even if you don't care about that, somebody could monkey in the middle with them. And you don't want that. So how about if you use an encrypted protocol? And we did that kind of thing in Bastille, and it was pretty neat. It was pretty fun. And a whole lot of people used it, but we haven't been working on that for forever.
I think that was your original interview, was the focus here on Security Weekly. And your wife got hurt, and I felt bad because you were like still on the line doing the interview. I'm like, Jay, you need to go. And we were both like debating, like, does Jay stay? Does he go? And like, we both worked really hard to get to the point where you were on the show doing an interview, and I still feel bad about this for that to this day. But
well, she ended up very much okay.
That's good.
Although not my wife anymore. So it's
there you have it.
But I still hope she's doing really well. Anyway, I don't know. I'm sorry you felt bad. Yeah, that
we grow and we learn, right?
yeah, yeah.
Paul,
You've been with
occasionally you just grow. Let's be clear.
This is true.
Well,
or
I
shrink
don't know.
as
We
you get
stopped
older.
learning.
But you're still with obviously InGuardians. You're one of the original founding members of InGuardians, back before it was even called InGuardians. I remember that thing.
Yeah.
As well. Yeah. And so,
Yeah,
how long has InGuardians been a company?
We've been kicking around since 2004. I've held a bunch of titles, and right now, and about a year ago, I became the CEO over here. We've got a whole bunch of great people who are who work here. We've had a whole bunch of amazing people that have come through. Yeah, man, I'm tripping over my words. Sorry,
it's all right.
But yeah, InGuardians has been wonderful. Just a bunch of people who are. We've done a lot more focus on red team and pen test than when we started up, and we were doing all kinds of stuff back then. And it's been really interesting. It's been like being in the field this long. The field changes a ton, and that's actually one of the things I've liked the most about working in information security is that you have to keep learning. Like that was the big one for me. It was like when someone was trying to recruit me over to move back into computers from I was in a PhD program in math. I was like, well, is it kind of like a job is it a job where you just like learn how to do it and then you don't get to learn all that much each year? And my friend was like, oh no, it's the other thing. You will always feel like you don't know enough, and you'll always be right and you'll always be wrong. And it's so you're going to be learning up a storm. And I think he recruited me with promise of a book budget back when we read lots of paper books. Actually, I still do.
Mm-hmm.
Yeah.
And then, so you went from Bastille, and it seemed to me, now that I talk about it with you, right, that it was a logical progression into containers and Kubernetes, right? Because there's a lot of parallels there, and I think, our interests are somewhat similar in that, right? Like I was hardening Unix systems, and then I found your Bastille project, and I was like, oh, wow, JBeale's awesome. Like, this is great. This is what I need, right? And then I also kind of fell in love with, it's a love-hate relationship with containers. I don't do a lot in Kubernetes, right? I'm reading about it, right? But like I'm really into the container thing. I think that's a logical progression. Is that how you kind of fell into it?
Oh, absolutely. I mean, I've been just basically a Unix and Linux, person for a really long time, and that's where, similar to you, that's where a lot of my passion has lies, and a lot of my specialty when it came to attack and defense work was very much being the Linux person. And containers, as much as we like talk about Docker and whatnot, containers basically came out of, at least in their current form, they just came out of they were a kernel feature. They were features out of the Linux kernel where you could say, hey, I'm going to take some processes like running on this system, and I'd like to kind of put them in a box. But
yeah, it was like the evolution of a BSD jail and a cheroot, right?
Yeah, it was, but it was for a very specific purpose. Like basically, you had these companies that were trying to operate a platform as a service business. So they were saying like, wait, I want to, if we do this, instead of putting 10 virtual machines on a server, and I'll run your program in that virtual machine, but I can only get 10 to a server. They could go to like way higher density if they're like, you know what? Why don't we just like run one operating system on that server, and we're gonna let 100, we'll have 100 different programs that people are submitting. 100 different customers can all give us a program. We'll put that program on the server, and what kind of separation we have to do so that every one of those people gets their program on the server will feel like they've got their own machine. For the purposes that they need their own machine. So they all can listen on port 80 if they want to. We don't have to, we can make that happen. We can give every single one of those programs like their own view of the, view of networking. They'll get their own routing tables. They all get their own IP address.
And they all get their own storage.
We only do with virtual.
In their own storage too, which I thought was a pretty amazing thing, to combine in with this kind of mini
they're on view of the
right?
file system. And that can be like this one can have an NFS thing mounted, and this one might have a
shared volume, a bind mount. Yeah, and it's kind of a pain in the ass to configure, but it works fairly well. But also, I think from the running applications as a provider thing that you described, which is great, it also enabled this DevOps movement too. I don't remember where in history now we left off that all of a sudden Docker specifically has enabled this DevOps. What came first? Was it the Docker container or was it? I don't remember. We've had Gene on the show multiple times.
I was going to say we have to get remember. Gene Kim to
was it the chicken
Someone
or the
remembers?
egg? Yeah, it doesn't matter, but I think it's interesting that it enabled that whole DevOps, which is another reason that I have a love-hate relationship with containers, right? Is it enables this rapid development, rapid deployment, rapid testing was more what I was into, right? That I could build it and test it and then destroy it without going to ask someone to build me a bunch of VMs.
I mean, it's amazing, and when I'm in developer mode, this idea, the most radical part of that, whether you've ever gotten into DevOps as a model or whatever, the kind of most radical part of all of that for me is that idea of cattle not pets. Is this idea that hey, here's a container you're going to run your program in, the container crashes, or the container's having an issue, whatever. Kill the thing, change the change the file system that was providing it, change the configuration, start a completely new one. And when you're using containers, you can blow those suckers away constantly and easily, and that means there's all kinds of things that you get out of that in terms of reliability and in terms of being able to say, okay, I'm in development mode, I'm going to try a bunch of things, and I just start over very, very quickly. And because I can start over really, really quickly, I can make sure that I'm being really disciplined about how I'm doing it, so that I want to make a change instead of I'll get into that container and make some change, and if that works, then I will remember that change. I'll write it down or something, and then I'll make it to the backing image that's provided in the container. And it's no, when you're working, because the containers are so computationally or resource cheap to stand up, you can say, okay, I think I need to make a change, and you'll make a change to the image in the first place, and just start a new container based on that. I mean, kind of the goal is that we're almost never execing into the container and making some file system change.
Right.
And so now you start being able to say that whole thing's read only.
Architecture and security wise, right, there's a lot of implications here, and I want to get to the architecture piece, but what you just hit on was a security point for me, in that I can not just make code changes and rebuild my environment, I can update my operating system components and my libraries and everything, and then go build it out and test it and see if it works. And so if I need to be on the latest version of a Python library or a Node.js version or whatever, I can be just upgrade that and go test it, see if it works. And I think that's great for pushing forward. It's actually the model we adopted here for own internal purposes. Is I'm no, never pin a library to its version. Always build it with the latest, and if it breaks the code, let's fix the code and push a release, because I don't want all that technical debt. And that's one thing that containers in this technology enabled for me.
Yeah, absolutely.
I don't think you understand how Fortune 500 companies do technical debt, okay? Let's be clear on this. Technical debt is free, so they just keep piling it up.
That's right.
Okay? So, I mean, come on.
You got to accumulate as much as you can.
Happen?
It's free until you get ransomware or...
Yes, but that's after my 18 months of CISO time is up, so I don't care.
That's right.
Oh yeah, your stock vested, and then you're good. That's somebody else's problem.
So I guess
or the technical debt becomes a way to justify headcount. You're I need more people. I need more people. We've got a ton to do because this is really, really hard. And I mean, I think that's why sometimes you'll see companies just entirely not rebuild, but re-architect something that they had working, because they're just it's got so much technical debt. We're just so sick of it. It's gonna get replaced by another team that isn't so committed to whatever all those patterns were in the thing that had the technical debt. And when companies don't do that, sometimes their competitors come along and do the exact same thing.
Yeah, but
Anyway.
I want to talk about Kubernetes versus containers versus virtual machines versus cloud.
Sure.
Like I mean, you're way more into Kubernetes than I am, right? Like you spend a lot more time with it. I guess architecturally, maybe with a security spin, like how are we choosing between containers and cloud and Kubernetes? Like where do you see the best and worst applications of these technologies, Jay?
Wow, that's a really, really broad question. I mean, when you started to talk about being able to rebuild your environment from, being able to, rebuild your environment, press go anytime you wanted. Like there's some new, I'm just going to do do a kind of little Kubernetes pitch, as it were, for a second. Kubernetes is basically, people ask what the heck is a Kubernetes? And that's a really reasonable question. It's the first thing I talk about is suppose you've got one machine running Docker or running some container runtime, and it can stand up a bunch of containers. But what would happen, and each of those containers might be completely unique, but what happens when you want to basically have a kind of a data center that's, a data center, an entire operation that can be automated in a certain way. So there are a few. Wow, I'm like spinning. So one of those is you get that vulnerability, you get that log4j, and you're like, oh gosh, we gotta update that. We have to update our library. Just rebuild it. So Kubernetes has this kind of thing, and it's basically a kind of it's kind of a load balancer and this thing called deployment and a service. And basically what you can do is you can say, okay, I've got, I have this application, it's getting tons and tons of requests. I cannot let it go down, but I need to replace the library that's in it. Maybe because of a security issue, maybe because of some other thing, but I need to replace a library that's in it. When you've containerized it, you're like, okay, I know that in a given time there's like 20 copies of this program that are running and answering requests, and sometimes there's like 10, and sometimes there's 20, based on how much on like how busy that thing is. What you can do is say, okay, I've built I've built another version that just has that library changed and maybe a couple other things, and I want to just see, like, I can't handle any downtime. So I've got those 20 copies that are running right now of kind of the old thing, and they're making sure that we don't have downtime. So now what I'm going to do is I'm going to stand up just 1 or 3 copies of the new version of the container that has that updated library, whatever changes you're making. And I'm going to say that, like, the traffic that, like, say 75% of the traffic is going to go to the old containers, and 25% is going to go to that. And you're going to watch for failures. And if you have some kind of failures, if something goes wrong, you can just say, okay, screw it. Stop on the new one. I'll go keep working on that. All the other people, all those other requests that were coming in, the people who had problems will hit reload. All the other requests that are coming in will go to the containers that are running the old thing. But, now I'll come out with another version. That version, stand up my 3 or 5 containers with it. The traffic's starting to get load balanced between these. Is that working out? If that's working out, you say, okay, cool. Let me just make another experiment. And DevOps has a lot of experiments, right? You're like, okay, now it's 10 of each, 10 of the old, 10 of the new. Is everything good? Is the new thing holding up well under the pressure of taking half the traffic? If it is, cool. Let's scale up to the whole new thing, right? Takes
so Jay, this is why I've always felt that our users are the QA team, and this technology made that feasible.
Yeah, I mean,
everyone's like, aren't you going to?
The users always were the QA team. We always were. We still are.
I'm going to push it in production, and the user's going to test it. Like, that's. Aren't they
I mean, if we want to be fair to software developers, I'd say the users are the last stage of QA.
Yeah.
Maybe, the question is based on the company or the development group, like, are the users doing 5% of the QA or 95%? Like,
I mean, you could say the same thing for security. Like, if I put it up and I don't see that it gets hacked, that must mean it's secure, right? Maybe not. But I mean, what I more so approve of, right, is not just doing functional testing, not just regression testing and unit testing, but also security testing in the process before it lands in production, and then do what you described, Jay, to make sure that it actually runs in production, and that's more of a performance and There's a word for
Yeah.
that. There's another word for that.
Yeah.
Make sure it stands up in production under production load, right?
Yeah, and that's, I mean, that's like at the end of the day, the kind of case for Kubernetes over Docker, and I'm kind of almost making this case to you specifically, Paul, right? Because you're doing Docker a bunch. You've described the case for for Kubernetes over Docker is when you want a whole bunch of features and a bunch of those will be like a whole bunch of failure cases that just get handled automatically. That's kind of like one of the big places that Kubernetes shines, is being able to say like, hey, what happens if a service gets overloaded? Oh, we'll just scale up like incredibly quickly, like the speed of starting containers, not the speed of starting VMs. Well, we don't want to spend too much. It's like, well, what if we need more VMs? Well, that's okay. Like Kubernetes can watch for how loaded the cluster is and say, okay, all the VMs that I have that are running containers right now, they're pretty darn full. So let's add some more nodes to the cluster. Let's provision some more VMs and put things on there. And then a little bit later, we can say, okay, the things aren't that full. Let's scale back down. So it's kind of cool. It's really about automating a data center.
It's the way I understood it, but with more detail behind it, in that you do Kubernetes when you've got a serious workload that needs to scale up, and not just up, but also down.
Up and down. Yeah. Like we've seen. So at InGuardians, we do a ton of Kubernetes penetration testing, and a whole lot of the customers have been places doing data science, places doing machine learning, right. Where they have these things where it's like, I need a ton of compute. I've got a program at the moment. When I've finished writing this program in Python and I press go, I'd like a whole bunch of compute to go and run my program until completion. And then as soon as it's done, cool, give me the results and make the compute all go away. And I want to be able to do that as an end developer, or as like a lot of these clients are like, as one of 100 data scientists. No, I don't know exactly when I'll need that, and I only need it for a really short period of time. And you don't want to pay for a ton more than you need, but you do want your data scientists to be able to go nuts and do big, ask big questions, and Kubernetes, but cloud in general, and Kubernetes in particular, has been really good for that.
And it's interesting, Jay. We when I look at container security, right? I feel like there's a finite set of security controls that we've got a fairly good handle on, and a lot of people ignore it when they make containers. But I feel like you can kind of get your brain around it and have a more secure deployment, provided your fundamental building blocks of containers are good. When you move to Kubernetes, you've got a whole new, slightly different set of security concerns. So, like, what are some of the primary examples of some security vulnerabilities in Kubernetes that are highly specific to that are real gotchas?
Yeah. So, I mean, I think that when you take a program, this is with my attacker hat on. Kubernetes has been really, really fun, especially when I first got into it, because the defaults were not as strong. They're getting stronger, and and the kind of controls that are available are getting stronger. But it's kind of this, in some ways it's similar to cloud. Like, okay, you're hacking, you're a pen test company or what have you, or maybe you're a bad actor, or maybe you work at a company and you're on the red team, and you find some program you're able to pop, and so you've landed, you've got remote code execution, you're on something that looks like Linux, and you realize, if you're in a cloud provider, you realize, like, okay, so I'm now in a network, what can I do? And we all, like, everybody is an attacker, like, you're like, I'm in a network, can I move laterally, can I take over other things that are reachable from here? But as soon as you go to a cloud environment, you're like, I'm in a network, but I'm also in a cloud provider, and I may have, and being on this virtual machine I've just landed on, just thinking of the virtual machine case, like, let me go and ask the cloud provider's metadata API, do I have any kind of credentials that I can use to make API requests? And sometimes the answer is, yeah, it turns out the credentials this machine has, like things are really bad, credentials this machine has are sufficient to go and, make stand up new machines, take backups of machines drives, and just kind of like own the entire thing from a script.
Yeah.
And
because the keys are in an environment variable on the box.
Maybe. Well, sometimes it's an environment variable not on the box, but there's this kind of cool thing in cloud providers where
it's a web service.
Virtual machines. You can give containers their own identities, and their identity will and that identity, that kind of that cloud provider IAM identity will have the ability to use APIs. And with some cloud providers, those you're like, I can read every single bucket. The buckets, these storage buckets, like S3 buckets or GCS buckets, they're not publicly readable. But if you're in one of those instances and you can get anything, sometimes the misconfiguration is it's not publicly readable by the world at large, but it's publicly readable by any machine that's in that, that's in the VPC, that's in the virtual network.
Right. And Kubernetes is a similar kind of thing if you don't configure it correctly.
So Kubernetes, exactly. Yeah. So Kubernetes can be a similar kind of thing if you don't configure it. And I'm trying to think of some of the cool ones that we've used in the past.
Secrets management. Secrets management still is not great in Kubernetes by default, right? Aren't they for a while?
No, they're great products though.
They're great. But in Kubernetes, it's like base 64 encoded secrets is how they're protecting them. Yeah.
But there's authorization. Like you're like, okay, I land in a pod. That pod's got a service account that's mounted in by default. What can that service account do?
And
sometimes that service account can
I'm sorry, Jake. Go back to Kubernetes 101. A pod is.
Sure.
A pod is.
A
pod is a cluster of containers within Kubernetes. Is that?
Yeah.
That
so
right?
you've got Kubernetes has nodes. Those are all the machines, whether they're virtual machines or physical machines.
So nodes are also my containers.
Nodes are where you put your containers.
Okay, exactly. Nodes go inside of a container goes inside of a node.
Container goes inside of a node.
Gotcha.
And when you stage a container to a node, they have this thing called a pod. You can't stage a container basically to a node without staging it as part of a pod. And a pod is like a container plus a little bit of extra stuff.
I gotcha. So your nodes go inside of the pod.
Pods go on nodes.
Pods go on nodes.
And so you got nodes. You put pods on them, and those pods have one or more containers in each pod.
Gotcha.
And if you got two containers in the same pod, they can talk to each other on their on localhost. They can talk to each other. They share a network stack together. And they will share access to the same storage. So you'll stick two things in the same. You'll stick two containers in the same pod if they have to be staged to the same machine, or if one of them is going to be a direct helper to another one, maybe serving as a proxy to it.
Yeah, in my containers, right? I've got a web server, I've got an app server. A lot of times they need to share, web server needs to serve files, and web server certain requests needs to proxy those over to that app server, right? So they need to share storage and networking.
Yeah, if they have to be on the same machine, then you stick them in a pod together. If they they don't have to be. You don't, because you'd like the web server and the app server to be able to scale differently. You might need, it might turn out that you can handle 10 replicas of your web server, but to do, but when things get loaded, but you actually need 40 of your app servers. So,
and so those would be in separate pods those
will be in separate pods.
I got you.
There's not too much where you stick two containers in the same pod. I kind of, but anyway, Kubernetes is crazy because there's, you can do it really, really badly, or you can do it really, really tightly. I mean, it's the awesome thing I think you've probably found with containers already, just using Docker, is that because you're doing one program, one application per container, you really, really that's a much simpler situation than a lot of computers. And so you really, really know what that application does. And if you know what it does, then you can put some pretty tight controls. You can create kind of a profile for that container and enforce. What's great is like Linux stuff. You can enforce AppArmor profiles onto the container, and it's a lot easier because you know exactly what that container is supposed to do because because you've gone down to the level of one program.
But you can change the AppArmor profile at run. Like, you don't need to be the developer, in other words, to change the AppArmor profile and the Linux not privileges. What do they call that? Well, if you run it with privilege, it runs with all of the. What is that called?
Yeah.
Like, I'm drawing
but those capabilities,
thank you,
or the syscalls.
But
totally.
It sounds like Kubernetes suffers from the same thing. I can write a pretty secure app and even like develop a pretty secure container build, but now I give it off to what usually today is a site reliability engineer, and if they want to screw it up, they can, because they can muck with the AppArmor profile, they can muck with what privileges that it runs on, and in Kubernetes they can muck with the privileges between pods and containers and all that stuff and screw it up.
Yeah, I mean and usually the concern's the other direction, is that you're the person running the cluster, and what you're wanting to do is say, listen, if you want to put code in this cluster, then we want to have some minimum security standards. And one of those is, you don't want, like you mentioned, privileged containers. You don't want privileged containers because you get really, really, really easy container breakout if you do. Yeah. And Kubernetes by default will let all the containers be privileged. Mm-hmm. So like you were saying, like you were kind of asking, are there some gotchas, or are there some things that you should always be doing? And stock Kubernetes will let any developer who's able to give you a container image, give you what we call a manifest file, the kind of configuration for that image, end up with far more privilege than they should. And that can be that they can have container breakout. It can also mean, like, if things aren't well enough configured, either the developer or, more to the point, the developer's application, when it gets popped, the attacker doesn't just end up with remote code execution inside of one container. They can end up compromising the entire damn cluster. Mm-hmm. One of the fun and very simplistic cases of that was when there was a public hack where Tesla's Kubernetes cluster got popped. It wasn't used for cars. I think it was for machine learning, but that meant this whole cluster. Like, this cluster got popped, and it meant all the nodes in the cluster were now running, crypto mining software, and the thieves made a whole bunch of money off it. I guess there are a bunch of different kinds of gotchas.
And so the way I understand it as well is that you should still construct a very secure container environment, and that does help even if those are being deployed out into Kubernetes. You and I were talking about a point where I'm starting to reach with some of my container builds, which I hope other people have figured out and done in production, like where there is like no shell. Like, it's one thing to pare down the utilities, like,
hell yeah,
I shouldn't have wget and curl in my containers, and that's like container security 101. But the more advanced is like there actually, it's kind of funny, like there is no spoon, which is a throwback for you, Jay. But there is no shell, because I lock down a container so much, as an example, where there's no utilities. The only thing you have is bash, and it doesn't run as root, but you can still use dev TCP to construct a callback. And I did that in my lab. But I'm like, the next level of that is that this container is from scratch. So in container language, you say from, which is your base. Base container. Scratch is like nothing. Is it even just a kernel? I think you have to specify the kernel after that. So right?
The kernel's always there. You don't control that part. The from scratch means no files.
Right. The kernel's on the host.
And Google's got a variation of that. Like, if you can't go all the way to from scratch, they have a variation called distroless. And it's a bunch of container images that are like, this is the minimum of what you need to run Node.js. Or this is something that like has the very, very minimum of what you'd need to just run statically compiled programs.
But different when you do from Python or from Node in Docker. You get someone else's container build, which I want to say they've gotten a little better over the years, but that's like a whole bunch more stuff. I never do that. I like starting from my own build. But I think the next iteration of that is in Docker from scratch, where again your kernel's on your host, so you're starting with basically an empty Linux system that runs whatever kernel you got on your system, and you have to install everything from there. And if you don't install a shell, that's where I think we need to be.
Yeah, it's pretty awesome. It's pretty awesome because that's what really, really like gets you to that thing that I'm like to that thing that the promise for me is the because I'm always thinking from like containment. What can I do? An attacker pops a program. How rough can I make that attacker's life? First, can I break the exploit so it doesn't work in the first place? Second, if it does work, it gives them RCE. Can I make it so that RCE is half useless, so they have to bring everything of their own, and then a bunch of that doesn't work?
Yeah, it's really hard to do a container breakout without a shell. I haven't really like gone through every container breakout exploit and thought about how you would do it without a shell. I'm sure you can't. I'm sure there's a couple that you probably could. Being on the latest version of Docker probably really helps that. I think if you're probably on the latest version of Docker and you don't have a shell in your containers, like you're in really good shape. From that that perspective, there's still mistakes you can make, but from that perspective, you're in great shape.
I mean, it depends on what the attack. It depends on the sophistication of your attacker. I mean, if your attacker, it's the great thing is there are a ton of your attackers really just would get totally stuck.
Right.
But honestly, on the flip side, it's if I've got there and I'm providing my own shell code and I have the skill or the money, skill to create or the money to buy, or the time required, then we can break out of the container without needing a shell to do it.
Right.
Because like whenever you see these things where someone's using an unshare command, they're basically all that command's doing is basically saying, hey, Linux kernel, I'd like to switch namespaces, please.
Yep.
And all that's holding me in a container is that I'm in separate namespaces
within the kernel,
from everything else.
Yeah.
In particular from kind of the systemd's
Well, and then you could go through all that trouble and still leave your Docker API exposed to the internet, and that would be really bad.
Yeah. No, it's so I mentioned Tesla's thing earlier, by the way, and if I recall correctly, their deal was they'd left the Kubernetes dashboard, which is a web interface, lets you do lots of stuff. They'd left it unauthenticated, available to the internet. It was shocking they didn't get popped earlier. Yeah, so I'm hoping I'm remembering correctly, because there's some chance like this was like 5 years back, so it was quite a while ago. I'm not as young as I used to be. I used to have hair. Not
Josh did too,
but I had some.
I had hair 20.
Nice, Josh.
Wait, I had hair 20 years ago.
Yeah, I was gonna say when I first met you at conferences, you used to wear a hat though, so I can't really say with an accuracy.
No, I shaved my head. I started shaving my head when I was 27. So that's
about 50 years ago.
That's 23 years ago. Well, I'm 50 years old, so that's 23 years ago.
You're not that old. I can't crack too many old jokes because I'm not that far behind you.
I realized I'm at the age where when I open up a bottle of ibuprofen, I better have enough to go around.
Yes. We joke when I'm interviewing people for the new show that we're working on, Hacker Heroes. We're going back in history. Now, I was telling Jay I want to bring you on that show as well, and we talk about time frames. And like 2 or 3 times now, I've gone, oh well, we're really dating ourselves. Like, yeah, because we're like early 30s. Yeah, let's go with that.
Yeah, dude, our last guest, we were talking about identity and Azure Active Directory, and I'm like, yeah, I did Novell.
Yep.
God,
that was before my time. I saw people doing Novell when I was a teenager. I was working at a game company, and I remember them like laying down.
Shut up,
Novell.
kid! Get off my lawn.
You're now you're dating yourself as younger than us, Jay.
Well, that'd be nice. That doesn't happen very much for me. That would be great.
So I am curious, are we starting to see a lot of companies start to pivot to Kubernetes as a viable production technology solution? I mean, outside of like agile dev shops and people using it for dev, like the ability for this and the knowledge base needed in order to deploy this securely and with inside of a pipeline that makes sense on a production side. Like, what is the level that you guys are seeing for deployment and use cases in which this is done well?
I was about to, until you said done well, I was going to say, well, there's just tons of companies doing it, and there are a ton of companies doing it, and I've been shocked at how many of them aren't tech companies. Kubernetes has basically become really, really popular, it seems to me, in kind of two use cases. One is things like machine learning and data science, where you need an unpredictable amount of compute, and that amount of compute needs to be able to flex up and down very, very, very quickly. And that's kind of the one. I think the other that in a lot of ways, a lot of the Kubernetes features are designed for are companies that are using some of what you get out of container orchestration in how they develop software in the first place. And so it's being pushed often by their developers, and because it can change the way that they develop software. And one of the examples that I give, if you find any YouTube video I've done on Kubernetes, I've usually spent a little bit of time talking about like this microservices idea. This idea that like instead of saying, okay, I've got a bunch of developers, they're gonna, I have 50 developers, they're gonna write one program, and that program will release, once every 3 months, or once every 6 months, or once a year. There's, Mythical Man Month, a very, very old book. Basically what it said was if you double the number of developers, you won't double the speed at which they develop, because there's just a whole lot of communication and coordination time. And some of that coordination is basically saying, I can't move I'm blocked. I can't move any further on my part until so-and-so does their part. Mm-hmm. So the microservices model came along, and that microservices model is saying like, hey, take those 50 developers and say, screw it. Let's have five groups, 10 developers each. It's kind of that two pizza rule for meetings. Don't have a meeting or don't have a group bigger than could be fed by 2 pizzas in a meeting. You stick 10 developers and you say you're working on part A, 10 developers, you're working on B, C, D, and E. And instead of those parts being different parts of the program, each of those are separate programs. And so like all of what the program did, say, I'm just like thinking of an e-commerce site, like all of what the program did for like looking at, for pulling its inventory and seeing what we have, that's one separate program now. Those folks like create something and it has an API that all the other folks consume, and now they don't have to coordinate their releases or whatever. It's not kind of the dependency anymore. That's a versioned API. And then you've got, some other group that's doing the whole, like, we're going to read through the inventory and see what you've bought in the past and make recommendations for what you should buy now. That'll be another part. And in breaking it apart, everything, the development ends up being a heck of a lot faster and far less, and far less painful or far less frustrating. There's like fewer meetings. And I know that sounds strange that I'm talking about this kind of like development model with respect to Kubernetes, but a whole bunch of what Kubernetes has been good for is making it so that, you can have those 5 teams and they can all be releasing code at different times. And you have this like automated data center, which is in essence what Kubernetes is doing, that helps all the parts of the program find each other, helps them all scale at different levels, helps them handle just a whole bunch of what you're seeking in rapid, constant releasing development. So,
but then operational and security risk becomes a game of APIs. How well am I documenting my APIs and or providing backwards compatibility and forwards compatibility in my API? And how well am I locking down my API as to who can request what is what it becomes. And I guess it's a game of, it's a double-edged sword, right? Like it
always is.
Yeah.
And that's actually another fun of one of those Kubernetes gotchas. Like one of the like if you look at the Kubernetes documentation and it's talking about how networking works in a cluster, like by default, everything in the cluster can reach everything else in the cluster, and that's like a requirement. So segmentation, like saying, wait, what about some network segmentation? It's like you have on the one hand, I was telling you, each one program per container makes it a heck of a lot easier for you to create firewall rules around every single one program. But on the flip side, you're in this model of like everything's got to be able to reach everything, by default. Yeah. And so unless someone says, wait, we should do some network segmentation, there's kind of like a lot less than there was before.
Right. But we have that same segmentation problem that Sean was talking about in the earlier segment with the DMZ. Yeah, we've got 15 microservices, and they're all locked down, and they can all communicate with each other over port 443. And as an attacker, I'm like, okay, that's great. If I can control the API, I can control the entire application. I can extract data maybe that I shouldn't be able to extract.
But hey, I got to ask a question. Yeah.
What's up,
By the way, I dropped
in
the sky somewhere. No, I do have to ask a question, though. I mean, doesn't that ultimately imply that network has just become transport, and we have to accept that. So what's really happened there is we've moved the responsibility for securing the application to those individual microservices. Mm-hmm. That's actually what's happening here. What's your thought on that, Jay?
I mean, sort of. The cool thing. I feel like a salesperson for Kubernetes, oddly enough, but don't worry, it's free. But the cool thing, like when you do that orchestration, like when you do put every one program in a pod and all that, like if you take the time, you get much easier network segmentation in this kind of environment than you get in the like, well, it's all on port 80. What ports am I going to block? Kubernetes will let you say like, hey, I've got these different microservices, and if I know which ones should be allowed to talk to which ones, I don't have to track ports. I don't have to track IP address.
Okay, so those are all what ephemeral. I hear you saying.
Like, what I think you can do a default deny much more easily.
Layer 4,
it's just not there for free.
I'm sorry for talking over you.
No, I didn't mean to. I was just trying to. Yeah, go ahead, please.
No. What I think I hear you saying as a old curmudgeon-y network guy from way back is that OSI layer 4 becomes largely irrelevant, that the operating system, not the operating system, but the microservices architecture becomes one of making sure which servers can talk to which other. They're all talking port 443, so we don't care. It's more at layer 3 to control like who's talking to what, and that's sort of it. Is that what I'm hearing?
No, you still have it down to the port level, even in Kubernetes. Jay, is that true? Like
this is true. You do have it down to the port level.
You have both. This container can talk to this container.
Yeah, but
it can talk on this port.
But they're each listening on one. They're usually listening on only one port anyway. So you're basically saying like,
that's
like,
what I'm
hey,
saying.
any of the containers providing this app. Oh, go ahead. Sorry.
Oh, no, what I'm saying is why does the TCP port matter at all, right? It's all largely HTTPS, TLS, port 443. So the TCP port OSI layer 4 becomes completely irrelevant.
Yeah.
It's really more about which microservice is talking to which other microservice at layer 3.
You're right, Joff. I think you and Jay are saying the same thing, that like a service, when it runs, it only listens on one port anyway, because you're not running a full system that might be listening on a ton of ports. When you spin up an app server, it listens on a port. It's not even listening on any other ports because it's just that one service running in that microservice.
Right. Well, and there's something really cool. Like if you're up for the complexity, there's this thing called service mesh, like Istio and Linkerd and Console and Ambassador are these products, most of them open source, that can do this, where you can say, wait, I'm not even going to think about like, hey, I'm going to let this thing talk to this thing, and I'm going to actually enforce that this thing talks to this thing, and they're going to mutually authenticate via TLS, and the crypto there can actually be managed by something central. You don't have to figure out as a human being. All those things will have their own TLS keys. They'll mutually authenticate to each other. The keys will all get rotated automatically, so you don't have to follow that or figure out where you're going to store the keys. Jay, I'm sorry, if you put the time into the security, you get like a lot of really good results.
I'm sorry, and you can do this in AWS too with API Gateway, and I'm assuming other services that allow you to do that key-based authentication. Like this service can talk to this service. I always go through this broker to talk, and to Job's point, like layer 4 is kind of irrelevant at that point.
Yeah.
That's really cool.
Yeah, so I mean, I'm seeing this increasingly, right? So your old school, this is the thing. Like you go back 15, 20 years, right? The old school firewall architect would say, well, what TCP port is it communicating on? Can I lock that down? But that's actually irrelevant now, right? It's more, either application layer if you can see it, but frankly, TLS, perfect forward security, you can't see the network traffic, right? It's really just down to IPs to IPs, right? And when you're architecting this thing, I don't know. That's kind of what I'm seeing rinse out.
Yeah. Well, and the crazy thing is, like when you're talking about, when you're talking about using lots and lots of containers, so at the kind of scale that people are doing with Kubernetes, the IP addresses are the IP addresses of all these different things that are running in the cluster. They're ephemeral. Like the idea is that that a container can fail at any moment, and it's not that one thing wants to reach one other thing. It's that, like, hey, this service wants to reach one of the containers that are running, version 2 of this service. And so kind of the bulk of the network traffic that's happening in a cluster is all happening via these kind of internal load balancers. Those internal load balancers are called services, and they're at the end of the day, they're kind of using the Linux kernel's, IPVS and it's actually really, really beautiful. But it's also,
so Jay, question on that front is that in Kubernetes? So when I configure containers, I say like web server needs to talk to app server, and I name the containers, and it gets in there, and I'm like, this container can talk to this container by this name. Like IP addresses are irrelevant at that point. In Kubernetes, I can say this service can talk to this service, and it's like a service name. There could be multiple containers behind that name. Is that what you're describing?
Yeah, that's the idea. There could be multiple endpoints. It's like if everything talking to anything was going through a load balancer.
Right.
And those load balancers had names. So Kubernetes has this idea, like I talked about how like the number of nodes in the cluster can be flexing. Kubernetes has this idea that damn near everything should be capable of being killed off at any moment. Like if you think about like when Netflix made this Chaos Monkey, this really cool concept, this idea that like, hey, in our environment, you should be able to basically yank a cord. You should be able to yank one cord anywhere in the environment and have, and nobody should be unable to watch their movies. And that's basically one of the promises of when you are using container orchestration, when you're using Kubernetes, when you're using this kind of feature set, is that like at any given point, one of the machines that's part of your cluster should get to either fail or should get to be expelled from the pool and returned back to the cloud provider, and everything has to keep working. What features would you need to do that? And it's like, well, I'd have to stop thinking about IP addresses so much. I'd have to kind of just say, okay, all the, I'd have to the thing cloud providers have had us all do. Like I'd have to abstract. I'd have to take those things, I'd have to take those things and just start abstracting and saying like, okay, I don't know the IP addresses for anything that's providing that service, and it's possible that if I knew them right now, a bunch of them would be changed in a second, and I don't want anything to fail while I'm doing it. So, so how about if we say any container can fail, any machine in the whole thing can fail, and what I'm going to do is say, when I want that service, when I want version 2 of this API, I talk to this virtual IP address, and that virtual IP address is going to be routed to all the things that answer for that service. And all those things, we won't do it by names, we'll stick a label on all of them. And that label will be like version 2, and there'll be a label that will be like this service. And there might even, you could even think of it being as, there might even be a label that's like ready. And my traffic will automatically go to whatever things have those labels. And if one of them gets kind of overloaded, then my traffic won't go there. It's it's kind of like it's a way of being able to be super automated. And also the other weird thing and kind of cool thing in that model is it's instead of being an imperative model where you say like, hey, I'm going to configure my firewall and tell my firewall, you do this. You instead, basically, it's declarative. You say what you want the state of the data center to be. And then Kubernetes is basically a bunch of control loops that just keep checking. Like they're like, okay, you want the state to be like that? I'll go make it like that. And then I'll keep it like that. You can go to sleep now. If anything fails, if anything gets too busy, like if anything gets, I'll make sure that the state of the world still matches the, what you declared it should be.
But now you can do this in ECS, in Amazon's AWS. You can do this with load balancers in EC2 as well. Which the more I think about all these different architectures, my brain spins as to like, how would I deploy an application and how would I secure, right? Cool. And how would I secure this application? Because if it's Kubernetes or it's ECS or it's EC2 with load balancers, my security model might be slightly different between all three. And then I'm like, oh my God, this is crazy to think about how we secure all of this and deploy all of this. It's crazy.
But doesn't it look? I have a thought too, Paul. If you don't mind me jumping in,
go ahead.
I'm jumping in anyway. What the hell?
Please do.
The thought is that as you guys have probably already talked about before I jumped in rudely, that the control plane is critical, right?
Yes.
But B, whatever form of name resolution is being used also becomes really, really critical, right? Because that traditional model of, IP addresses don't mean anything. And we know that IP addresses don't mean anything. It's always been a form of transport. It should have been that way years ago. But name to number resolution becomes a very critical linchpin and an attack point potentially. What's your thought there, Jay?
Yeah, it really does.
Jay, just explain to us how Route 52 works in that situation.
That's kind of mean, Paul.
It's so mean. It's so mean because all of us have been doing DNS probably for a really long time, and
really freaking long time.
Now let's go try and explain Route 52, and it's like shit. Like Joff, to your point, like that's what I think Amazon's vision was for Route 52, right? Was to accomplish what you're accomplishing, abstract that name resolution away. But it's right. I'm like, I thought I knew DNS until I started reading about Route 52, and I'm like, what the hell? My brain hurts.
Right. I mean, you go back to the world of V4, and everybody was kind of hung up at dot quad or octet. Yeah, we can deal with that. Yeah. V6, nobody can deal with that.
I think in the same. But to your point, Joff, the same thing when we talk about newer cloud architectures and Kubernetes architectures, right? They're essentially accomplishing the same thing of abstracting that name resolution away, and it gets
and you know what? It's the right thing. I mean, it's the right way to go because we need to get to that level where this stuff is just transport, but it does become a potential vulnerable attack point, and that's where it could get interesting.
Yeah, I mean, what happens? So kind of what happens ideally is in Kubernetes, at least in its implementation, is that I've got, I have one program, and that one program needs to reach out to some service, and that service, when I'm saying a service, it needs to reach out to one of the containers that are offering this other program, and it can reach out by name. So it'll reach out in the name, like there's a well-defined, naming format. So it's kind of like the name of the service, the namespace. Don't worry about what a namespace is for now. That it's running in service cluster.local, and so you do a DNS request, and that DNS, the DNS server, that's there was a kubedns, there's core DNS, but there's an internal DNS server thing, and it gives you an IP address. Once it gives you that IP address doesn't land on. It's not like our old school like round robin DNS where you make a request and you kind of get 10 answers and pick one or what have you. It's that you get an IP address, and on the host you're on, like on the Kubernetes node, on the host you're on, your program makes a connection to that IP address, and that IP address kind of like doesn't exist. It's a virtual IP, and that virtual IP, think like kind of, to make it simple, think IP tables. Like that virtual IP immediately gets translated into one of the things that we should go to, and managing what that IP address gets translated into. That's Kubernetes taking care of that in the background. So on the one hand, it's kind of like there's less DNS to go wrong, and on the other hand, you're still very, very dependent on DNS because none of the IP addresses, or virtually none of the IP addresses in a Kubernetes cluster, can be counted on to not change.
Jay, I want to change.
Well,
gears.
you raised a good point, and that is the load balancing aspect and the virtual IPs, right? I mean, those things can be cached for a longer time, and so if DNS breaks or is attacked or whatever inside the Kubernetes control space, it might not be as impactful if there is that virtual IP presence that's supporting a whole slew of back-end microservices.
I wanted to change gears for a lot of reasons. One, because we're talking about DNS, and the other reason is we talked about kind of going back in the archives of Security Weekly. Jay, you were on earlier on in the show's history, as was Dan Kaminsky, which there are several people, unfortunately, which have passed away that we've interviewed in the past. And the more I kind of go back in the archives, so we're on a project, we're starting to go back in our archives and like remaster some of our older episodes and try and do that strategically. When you've got across all of our shows over 1,000 episodes, it's a really big effort. Of course, one of the ones that is near and dear to my heart is our interview with Dan Kaminsky. Jay, you were very close to Dan, probably one of in my circle of friends, the closest person to Dan that I knew. And here we are talking about DNS, and I don't want to ever stop talking about Dan and his contributions to the world and to cybersecurity, right?
Yeah. And I wasn't as close to him at the end, and for me that's a giant regret.
Many of us share that regret, Jay, right?
Yeah.
The pandemic,
but I can honestly say that, like, literally, 4 hours ago, just walking from my home office to, another room in my house, and I don't know, I think I heard something, I just read something about diabetes for a second, and I immediately went to the OF, Dan, why are you gone? Like, what the hell? So I'm not saying that happens to me every day, but I think it still happens to me every week. Yeah, he was one of the greatest of us. He was, for his contributions, for his research contributions, for his showmanship, absolutely. But he was, he was a really amazing human being in how giving he was, like in how much he constantly, would in a conversation give the spotlight in a like that, like there's so much of that, like, him grabbing two people and saying, like, hey, like, you should really know this person. They're a hero because X, and also you should really know this person because they're a hero because of Y. And he meant it. He was just really, personally generous that way. And I don't know why I'm saying that. I don't know why I'm sharing that particular part of that. I'm not sure what you want to talk about, but
no, I think
sharing
comes to me
immediately.
Yeah, I think sharing what we remember of Dan is important, and I think many of us think about him, like you said, Jay. If not every day, very frequently, all of us collectively think about Dan, and we don't always come on the podcast and talk about how we remember Dan in a specific way. And I thought it was a great way to do that, today. And again, I don't want to stop remembering all of his contributions and just in the way he interacted with people. Like I said when we gave the initial oh my God, I can't believe this on the podcast. Dan always supported not just us at Security Weekly, but everyone, right? Yeah. And that was what I think many maybe didn't see, that didn't get to know, although Dan got to know a lot of people. He was a very social person for sure. But to know that he had that effect on us, that many of us in security, right, and supported us. And early days of the show, he's like, "Oh, you guys are doing awesome work." I'm like, "Really? Like, you actually know we're doing a podcast? Like, that's amazing."
He was a really sweet guy, and he had this part of him also that was just very, very childlike in some of the best ways. Like, and I feel like that was part of what was fun was Dan was enthusiastic about everything.
Yeah.
And he made you feel that. He got you enthusiastic about everything. And
Yes.
And that kind of childlike glee, you know, you can see it in a public talk, but you could see it in any conversation he was in. It was really cool. And
it's so true. It's so true.
Yeah.
Look, I had only a passing acquaintance with Dan, but the sort of one or two times I spoke to him at a con, the enthusiasm was the thing I remember, right? That you just had to feel like you were involved,
Yes.
the way he presented things to you. And that was fantastic.
But
that was real
interesting on a positive note that I think that we have to have with Dan, because he was so positive all the time, right? Is like many are talking like, oh, I don't know how many security conferences I'm going to go to, but all of us have shared our brief encounter. Even brief encounters with Dan at a conference was an amazing thing. I think that's kind of I think not just for Dan, but for the community and for yourselves to get out to a conference, because there's many of us that are like, oh, I'm cutting back on my travel. And I get it, but as things open up, I implore you to reconsider and hang out in person at conferences, because if
Definitely.
you don't, you might miss hanging out with someone like Dan. And
It's a really good point.
And Joff and I and Jay and so many others, right? Like
We're hanging out with Jay,
we remember hanging out with Dan and so many other people, and not those people. We're all not going to be around forever, so we should hang out together.
No,
at
it's a
conferences.
really good point. I'm so eager for the FDA to approve a vaccine for my for people my daughter's age. My daughter's 4 now, and
you're not the only one
golly,
in that boat,
I
Jay.
swear
Certainly.
the number of airline tickets I feel like I'm going to buy as soon as she starts to get her shots. And I think you're really right. Like, I think, like, I've started. I've been to a couple conferences during the pandemic, and I've started. You asked about InGuardians earlier. Like, I went to I went into our office at the same time as a bunch of other people recently, like a couple weeks ago, for the first time in a while, where it wasn't where a bunch of us were getting together in the office, and it felt so good. And this is just us working together in an office. This isn't even hanging out.
Right.
But like the degree to which we all really need that social contact, and I don't know. There's a ton that happens at conferences. Like you talk to people you talk to people that you'd never get to talk to, like even just because there wouldn't be time to talk to them all, and you'll end up at a LobbyCon at any conference, and there's just so many people that you'll meet and get introduced to, and you'll learn a bunch. You'll find out other people are interested in what you're interested in, or you're just, it's really nice. So I'm really eager. I know my first, the first conference I'm absolutely certain I'm going to in person is Black Hat this summer. I teach a class every year. Yeah, I'm finally.
So give me your plugs.
It's time to come in person.
Yeah, give me your plugs. On a much lighter note, right? Let's.
Oh, sure.
You've got a couple of projects, and you're training at Black Hat, right?
Yeah. So absolutely happy to plug. Find InGuardians website. I'll throw it over for the show notes. Find InGuardians website. We have a Kubernetes page where you'll find some free resources. One of the things that I made sure that we're posting today is we do a free workshop every now and then, where for a couple hours we'll get you on a Kubernetes cluster and teach you how to do things with it.
Oh wait, that's free. That's free.
Yeah, just every now and then.
Nice.
I'm doing one at Wild West Hackin' Fest Way West, and and that's in May, and in June InGuardians is hosting one. And then in September, InGuardians is hosting another one. So we're trying to do it, kind of like an every 3 months thing. And we basically, you don't have to bring any VMs. You just have to You just have to have a remote desktop client or a no machine client, and we give you a Kali system that's got a 3-node Kubernetes cluster. So more than just a mini kube, like single thing you can spin up. You get a whole cluster that's real, and give you an exercise where you can hop around between the nodes and kind of see what you can do as an attacker when things aren't strong enough. So anyway, take a look at InGuardians' website for that. It's like inguardians.com/Kubernetes. You'll find on there, we have a pen test tool called Peirates that's written in Go. And Peirates is Kubernetes is the Greek word for helmsman. Peirates is the Greek word for pirates.
Oh, brilliant.
Nice.
Yeah. So we've got a cluster that needs an update right now, so please wait a week to download it. But Bastille is a learning cluster we make that you can download, and you get a 3-node cluster, and there are some fun little Matrix-inspired attack and defense exercises.
Nice.
And another one is that some of the folks at InGuardians and I, and it started to be other companies as well, put on the Kubernetes Capture the Flag at DEF CON each year. We've done it one DEF CON and 2 of the DEF CON New Year's Eve things, and it can be fun to play in. And if you're not competing, you can come to learn, and that's what we do on the New Year's Eve ones. Find InGuardians on Twitter. We're doing lots of fun stuff. If you want to learn about Kubernetes, come take a free workshop or come take a longer, the Black Hat class is a 4-day class. Come take a class. We've got lots of videos, so there's lots of stuff you can learn with and play with. And if you want to learn Go, or if you've already learned Go and you want to work on Peirates, we're really always eager for more help. I mean, you can help by making feature requests, but you can also help by writing code, and we really
write some code.
Awesome.
Yeah.
Jay.
And then I guess the other thing I'd say is there's lots of, I do say, go check out the Kubernetes project. The security people in that project are like really, really smart, really, really motivated, and they're doing all kinds of awesome stuff. I know you've had a few of them on the show.
Hey, I just want to throw in there that I did participate in some of the early stuff that Jay was doing at one point. I don't remember when, Jay, but it was fantastic. I really enjoyed it.
Oh yeah, I remember that. Class. Yeah. Thank you. Thank
Awesome.
you. We end up with the best students.
Yeah, it was a lot of fun. But anyway,
Jay, thank you so much for coming back on Paul Security Weekly.
Oh my God,
it was
thank you for having
catching
me.
up with you. With that, we're going to take a short break and come up with security news. Stay tuned.